Can you kind of give your wise sage advice about what humans who have never interacted with AI systems, not even like with Wolfram Alpha, are now interacting with ChatGPT because it's accessible to a certain demographic that may have not touched AI systems before. What do we do with truth? Like journalists, for example.
Yeah.
How do we think about the output of these systems?
I think the idea that you're going to get factual output is not a very good idea. I mean, it is a linguistic interface. It is producing language, and language can be truthful or not truthful. And that's a different slice of what's going on. I think that, what we see in, for example, go check this with your fact source, for example.
Mm-hmm.
You can do that to some extent, but then it's going to not check something. It's going, that is, again, a thing that is sort of does it check in the right place? I mean, we see that in, does it call the Wolfram plugin in the right place? Often it does. Sometimes it doesn't. I think the real thing to understand about what's happening is, which I think is very exciting, is kind of the great democratization of access to computation.
Yeah.
And I think that when you look at sort of there's been a long period of time when computation and the ability to figure out things with computers has been something that kind of only the druids at some level can achieve. I myself have been involved in trying to sort of de-druidify access to computation. I mean, back before Mathematica existed, in 1988, if you were a physicist or something like that, and you wanted to do a computation, you would find a programmer, you would go and, delegate the computation to that programmer. Hopefully they'd come back with something useful. Maybe they wouldn't. There'd be this long, multi-week, loop that you go through. And then it was actually very, very interesting to see 1988, like first people like physicists, mathematicians, and so on, then lots of other people. But this very rapid transition of people realizing they themselves could actually type with their own fingers and, make some piece of code that would do a computation that they cared about. And, it's been exciting to see lots of discoveries and so on made by using that tool. And I think the same thing is, and we see the same thing, Wolfram Alpha is dealing with, it is not as deep computation as you can achieve with whole Wolfram Language Mathematica stack. But the thing that's, to me, particularly exciting about kind of the large language model linguistic interface mechanism is it dramatically broadens the access to kind of deep computation. I mean, it's kind of like one of the things I've sort of thought about recently is, what's going to happen to all these programmers? What's going to happen to all these people who, a lot of what they do is write slabs of boilerplate code.
Mm-hmm.
And in a sense, I've been saying for 40 years, that's not a very good idea. You can automate a lot of that stuff with a high enough level language. That slab of code that's designed in the right way, that slab of code turns into this one function we just implemented that you can just use. Mm-hmm. So in a sense, the fact that there's all of this activity of doing sort of lower level programming is something, for me, it seemed like, I don't think this is the right thing to do. But, and lots of people have used our technology and not had to do that. But the fact is that that's, so when you look at, I don't know, computer science departments that have turned into places where people are learning the trade of programming, so to speak, it's sort of a question of what's going to happen. And I think there are two dynamics. One is that kind of boilerplate programming is going to become, it's going to go the way that assembly language went back in the day, mm-hmm. of something where it's really mostly specified by, at a higher level, you start with natural language, you turn it into a computational language. You look at the computational language, you run tests, you understand that's what's supposed to happen. If we do a great job with compilation of the computational language, it might turn into LLVM or something like this. But or it just directly gets run through the algorithms that we have and so on. But then, so that's kind of a tearing down of this kind of this big structure that's been built of teaching people programming. Mm-hmm. But on the other hand, the other dynamic is vastly more people are going to care about computation. So all those departments of, art history or something that really didn't use computation before now have the possibility of accessing it by virtue of this kind of linguistic interface mechanism.
And if you create an interface that allows you to interpret debug and interact with the computational language, then that makes it even more accessible.
Yeah. Well, I mean, I think the thing is that right now, the average, art history student or something probably isn't going to, they don't think they know about programming and things like this. But by the time it really becomes a kind of purely, you just walk up to it, there's no documentation, you start just typing, compare these pictures with these pictures and, see the use of this color, whatever, and you generate this piece of computational language code that gets run, you see the result, you say, oh, that looks roughly right, or you say that's crazy. And maybe then you eventually get to say, well, I better actually try and understand what this computational language code did. And that becomes a thing that you learn. Just like, it's kind of an interesting thing because unlike with mathematics, where you kind of have to learn it before you can use it, this is a case where you can use it before you have to learn it.
Well, I got a sad possibility here, or maybe exciting possibility, that very quickly people won't even look at the computational language. They'll trust that it's generated correctly as you get better and better at generating that language.
Yes, I think that there will be enough cases where people see, because you can make it generate tests too.
Yes.
And so you'll say, we're doing that. I mean, it's a pretty cool thing, actually.
Yes.
Because you say, this is the code, and, here are a bunch of examples of running the code.
Yeah.
Okay, people will at least look at those, and they'll say that example is wrong, and, then it'll kind of wind back from there. And I agree that the kind of the intermediate level of people reading the computational language code, in some cases people will do that, in other cases people just look at the tests, or even just look at the results. And sometimes it'll be obvious that you got the thing you wanted to get because you were just describing, make me this interface that has two sliders here, and you can see it has those two sliders there, and that's the result you want. But I think, one of the questions then is, in that setting where, you have this kind of broad ability of people to access computation, what should people learn? In other words, right now, you go to computer science school, so to speak, and a large part of what people end up learning, I mean, it's been a funny historical development because back, 30, 40 years ago, computer science departments were quite small, and they taught, things like finite automata theory and compiler theory and things like this. A company like mine rarely hired people who'd come out of those programs because the stuff they knew was, well, I think it's very interesting. I love that theoretical stuff, but it wasn't that useful for the things we actually had to build in software engineering. And then kind of there was this big pivot in the 90s, I guess, where there was a big demand for sort of IT type programming and so on, and software engineering, and then big demand from students and so on. We want to learn this stuff, and I think the thing that really was happening in part was lots of different fields of human endeavor were becoming computational. For all X, there was a computational X, and this is and that was a thing that that people were responding to, but then kind of this idea emerged that to get to that point, the main thing you had to do was to learn this kind of trade or skill of doing, programming language type programming. And that, it kind of is a strange thing actually, because I remember back when I used to be in the professoring business, which is now 35 years ago. So gosh, that's a rather long time.
Time flies.
It was right when there were just starting to emerge kind of computer science departments at sort of at fancy research universities and so on. I mean, some had already had it, but the other ones that were just starting to have that. And it was kind of a thing where they were kind of wondering, are we going to put this thing that is essentially a trade-like skill, are we going to somehow attach this to the rest of what we're doing? And a lot of these kind of knowledge work type activities have always seemed like things where that's where the humans have to go to school and learn all this stuff, and that's never going to be automated.
Yeah.
And, it's kind of shocking that rather quickly, a lot of that stuff is clearly automatable.
Yeah.
And I think, but the question then is, okay, so if it isn't worth learning kind of, how to do car mechanics, you only need to know how to drive the car, so to speak.
Mm-hmm.
What do you need to learn? And, in other words, if you don't need to know the mechanics of how to tell the computer in detail, make this loop, set this variable, set up this array, whatever else. If you don't have to learn that stuff, you don't have to learn the kind of under the hood things, what do you have to learn? I think the answer is you need to have an idea where you want to drive the car. In other words, you need to have some notion of, you need to have some picture of sort of what the architecture of what is computationally possible is.
Well, there's also this kind of artistic element of conversation, because you ultimately use natural language to control the car. So it's not just the where you want to go.
Well, yeah, it's interesting. It's a question of who's going to be a great prompt engineer.
Yeah.
Okay. So my current theory this week, good expository writers are good prompt engineers.
What's an expository writer? So like
somebody who can explain stuff well.
Huh. But which department does that come from?
In the university?
Yeah.
I have no idea. I think they killed off all the expository writing departments.
Well, there you go. Strong words with Stephen Wolfram.
Well, I don't know. I'm not sure if that's right. I mean, I actually am curious because, in fact, I just sort of initiated this kind of study of what's happened to different fields at universities. Because, there used to be geography departments at all universities, and then they disappeared. Actually, right before GIS became common, I think they disappeared. Linguistics departments came and went in many universities. And it's kind of interesting because these things that people have thought were worth learning at one time, and then they kind of die off. And then, I do think that it's kind of interesting that for me, writing prompts, for example, I realize, I think I'm an okay expository writer. And I realize when I'm sloppy writing a prompt and I don't really think, because I'm thinking I'm just talking to an AI. I don't need to, try and be clear in explaining things. That's when it gets totally confused.
And I mean, in some sense, you have been writing prompts for a long time with Wolfram Alpha, thinking about this kind of stuff.
Yeah.
How to convert natural language into computation.
Well, right. But that's the one thing that I'm wondering about is, it is remarkable the extent to which you can address an LLM like you can address a human, so to speak. And I think that is because it learnt from all of us humans. It's the reason that it responds to the ways that we will explain things to humans is because it is a representation of how humans talk about things. But it is bizarre to me, some of the things that kind of are sort of expository mechanisms that I've learnt in trying to write clear, expositions in English that, just for humans, that those same mechanisms seem to also be useful for the LLM.
But on top of that, what's useful is the kind of mechanisms that maybe a psychotherapist employs, which is a kind of like almost manipulative or game theoretic interaction, where maybe you would do with a friend, like a thought experiment, that if this was the last day you were to live, or if I ask you this question and you answer wrong, I will kill you. Those kinds of prompts seem to also help.
Yes.
In interesting ways.
Yes.
So it makes you wonder, like the way a therapist, I think, would, like a good therapist, probably we create layers in our human mind between the outside world and what is true to us, and maybe about trauma and all those kinds of things. So projecting that into an LLM, maybe there might be a deep truth it's concealing from you. It's not aware of it. To get to that truth, you have to really manipulate the thing.
Yeah, right. It's like these jailbreaking things for LLMs.
But the space of jailbreaking techniques, as opposed to being fun little hacks, that could be an entire system.
Sure. Yeah, I mean, just think about the computer security aspects of how phishing and computer security, phishing of humans and phishing of LLMs they're very similar kinds of things. But I think, I mean, this whole thing about kind of the AI wranglers, AI psychologists, all that stuff will come.
Yeah.
The thing that I'm curious about is right now, the things that are sort of prompt hacks are quite human. They're quite sort of psychological human kinds of hacks. The thing I do wonder about is if we understood more about kind of the science of the LLM, will there be some totally bizarre hack that is, like repeat a word 3 times and put a this, that, and the other there, that somehow plugs into some aspect of how the LLM works, that is not, that's kind of like an optical illusion for humans, for example, like one of these mind hacks for humans. What are the mind hacks for the LLMs? I don't think we know that yet.
And that becomes a kind of us figuring out, reverse engineering the language that controls the LLMs. And the thing is, the reverse engineering can be done by a very large percentage of the population now because it's natural language interface.
Right.
It's kind of interesting to see that you were there at the birth of the computer science department as a thing, and you might be there at the death of the computer science department as a thing.
Well, yeah, I don't know. There were computer science departments that existed earlier, but the ones, the broadening of every university had to have a computer science department. Yes, I watched that, so to speak. But I think the thing to understand is, okay, so first of all, there's a whole theoretical area of computer science that I think is great, and that's a fine thing. In a sense, people often say any field that has the word science tacked onto it probably isn't one.
Yeah,
and
strong words,
right?
Let's see, nutrition science, neuroscience.
That one's an interesting one because that one is also very much, that's a ChatGPT informed science in a sense, because it's kind of like the big problem of neuroscience has always been we understand how the individual neurons work. Mm-hmm. We know something about the psychology of how overall thinking works. Yeah. What's the kind of intermediate language of the brain? And nobody has known that. And that's been, in a sense, if you ask, what is the core problem of neuroscience? I think that is the core problem. That is, what is the level of description of brains that's above individual neuron firings and below psychology, so to speak? And I think what ChatGPT is showing us is, well, one thing about neuroscience is, one could have imagined there's something magic in the brain. There's some weird quantum mechanical phenomenon that we don't understand. One of the important, discoveries from ChatGPT is it's pretty clear, brains can be represented pretty well by simple artificial neural net type models. And that means that's it. That's what we have to study. Now we have to understand the science of those things. We don't have to go searching for, exactly how did that molecular biology thing happen inside the synapses and, all these kinds of things. We've got the right level of modeling to be able to explain a lot of what's going on in thinking. We don't necessarily have a science of what's going on there. That's a remaining challenge, so to speak. But we know we don't have to dive down to some different layer. But anyway, we were talking about things that had science in their name. Yes. And I think that what happens to computer science? Well, I think the thing that there is a thing that everybody should know, and that's how to think about the world computationally. Mm-hmm. And that means you look at all the different kinds of things we deal with, and there are ways to kind of have a formal representation of those things. It's like, well, what is an image? How do we represent that? What is color? How do we represent that? What is, what are all these different kinds of things? What is, I don't know, smell or something? How should we represent that? What are the shapes, molecules, and things that correspond to that? What is, these things about how do we represent the world in some kind of formal level? And I think my current thinking, and I'm not real happy with this yet, but it's kind of computer science is kind of CS. Mm-hmm. And what really is important is kind of computational X for all X. Mm-hmm. And there's this kind of thing which is kind of like CX, not CS. Mm-hmm. And CX is this kind of computational understanding of the world that isn't the sort of details of programming and programming languages and the details of how particular computers are made. It's this kind of way of formalizing the world. It's kind of a little bit like what logic was going for back in the day. Mm-hmm. And we're now trying to find a formalization of everything in the world. And you can kind of see, we made a poster years ago of kind of the growth of systematic data in the world. Mm-hmm. So all these different kinds of things that, there were sort of systematic descriptions found for those things. Like, at what point did people have the idea of having calendars, dates, a systematic description of what day it was? At what point did people have the idea, systematic descriptions of these kinds of things? And as soon as one can, people, as a way of sort of formulating how do you think about the world in a sort of a formal way, so that you can kind of build up a tower of capabilities. You kind of have to know sort of how to think about the world computationally. It kind of needs a name, and it isn't. We implement it with computers. So we talk about it as computational, but really what it is a formal way of talking about the world. What is the formalism of the world, so to speak? And how do we learn about kind of how to think about different aspects of the world in a formal way?
So I think sometimes when you use the word formal, it kind of implies highly constrained. And perhaps doesn't have to be highly constrained. So computational thinking does not mean like logic, I suppose. No. It's a really, really broad thing. I wonder if you think natural language will evolve such that everybody's doing computational thinking.
Yes. Well, so one question is whether there will be a pigeon of computational language and natural language.
Yeah.
And I found myself sometimes, talking to ChatGPT, trying to get it to write Wolfram language code, and I write it in pigeon form. Yeah. So that means I'm combining, nest list, this collection of, whatever, nest list is a term from Wolfram language, and I'm combining that. And ChatGPT does a decent job of understanding that pigeon. Probably would understand a pigeon between English and French as well, of a smooshing together of those languages. But yes, I think that's far from impossible.
And what's the incentive for young people that are like 8 years old, 9, 10, they're starting to interact with ChatGPT to learn the normal natural language, right? The full poetic language. Why? The same way we learn emojis and shorthand when you're texting,
yes,
they'll learn, like, language will have a strong incentive to evolve into maximally computational kind of language.
Perhaps. I had this experience a number of years ago. I happened to be visiting a person I know on the West Coast who's worked with a bunch of kids aged, 10, 11 years old or something, who'd learnt Wolfram language really well. Mm-hmm. And these kids learnt it so well, they were speaking it. Mm-hmm. And so show up and they're like saying, oh, this thing, and they're speaking this language. I'd never heard it as a spoken language. Yeah. They were very disappointed that I couldn't understand it at the speed that they were speaking it. It's like and so I think that's I've actually thought quite a bit about how to turn computational language into a convenient spoken language. I haven't quite figured that out.
Oh, spoken, because it's readable, right?
Yeah, it's readable as a way that we would read text. Yeah. But if you actually want to speak it, and it's useful, if you're trying to talk to somebody about writing a piece of code, it's useful to be able to say something, and it should be possible. And I think it's very frustrating. It's one of those problems. Maybe this is one of these things where I should try and get an LLM to help me.
How to make it speakable? Maybe it's easier than you realize when you.
I think it is easier. I think it's one idea or so. I think it's going to be something where, the fact is it's a tree-structured language, just like human language is a tree-structured language. And I think it's going to be one of these things where one of the requirements that I've had is that whatever the spoken version is, that dictation should be easy. Mm-hmm. That is, that it shouldn't be the case that you have to relearn how the whole thing works. It should be the case that, that open bracket is just a or something. And it's, and then... but, human language has a lot of tricks that are, for example, human language has features that are sort of optimized, keep things within the bounds that our brains can easily deal with. Mm-hmm. Like I tried to teach a transformer neural net to do parenthesis matching. Mm-hmm. It's pretty crummy at that. And then ChatGPT is similarly quite crummy at parenthesis matching. You can do it for small parenthesis things, for the same size of parenthesis things, where if I look at it as a human, I can immediately say these are matched, these are not matched. Mm-hmm. But as soon as it gets big, as soon as it gets kind of to the point where sort of a deeper computation, it's hopeless. Yeah. But the fact is that human language has avoided, for example, the deep subclauses. We don't, we arrange things so we don't end up with these incredibly deep things because brains are not well set up to deal with that. And it's found lots of tricks. And maybe that's what we have to do to make sort of a spoken version, a human speakable version, because what we can do visually is a little different than what we can do in the very sequentialized way that we hear things in the audio domain.
Let me just ask you about MIT briefly. So there's a College of Engineering and there's a new College of Computing. It's just interesting. I want to linger on this computer science department thing. So MIT has EECS, electrical engineering, computer science. What do you think College of Computing will be doing, like in 20 years? What, like?
Well, you see,
What happens to computer science? Like, really?
This is the question. This is, everybody should learn kind of whatever CX really is.
Mm-hmm.
Okay, this how to think about the world computationally. Everybody should learn those concepts, and it's and some people will learn them at a quite formal level, and they'll learn computational language and things like that. Other people will just learn, sound is represented as digital data, and they'll get some idea of spectrograms and frequencies and things like this. And maybe that doesn't, or they'll learn things like, a lot of things that are sort of data science-ish, statistics-ish. Like if you say, oh, I've got these people who picked their favorite kind of candy or something,
Mm-hmm.
and I've got, what's the best kind of candy, given that I've done this sample of all these people and they all ranked the candies in different ways.
Mm-hmm.
How do you think about that? That's sort of a computational X kind of thing. You might say, oh, I don't know what that is. Is it statistics? Is it data science? I don't really know.
Mm-hmm.
But kind of how to think about a question like that.
Oh, like a ranking of preferences.
Yeah. And then how to aggregate those ranked preferences into an overall thing. How does that work? How should you think about that? Because you might just tell ChatGPT sort of, I don't know, even the concept of an average. It's not obvious that, that's a concept that it's worth people knowing. That's a rather straightforward concept. People, have learned in kind of mathy ways right now. But there are lots of things like that about how do you kind of have these ways to sort of organize and formalize the world.
Mm-hmm.
And and these things, sometimes they live in math, sometimes they live in I don't know what I don't know what, learning about color space. I have no idea what, there's obviously a field of.
It could be vision science or color space, that would be optics. So like, depending.
Not really. It's not optics. Optics is about, lenses and chromatic aberration of lenses and things like that.
So color space is more like design and art? Is that?
No, it's like, RGB space, XYZ space, hue, saturation, brightness space, all these kinds of things. These different ways to describe colors.
Right. But doesn't the application define what that, because obviously artists and designers use the color space to explore.
Sure. No, it's just an example of kind of how do you, the typical person, how do you describe what a color is? Yeah. Oh, there are these numbers that describe what a color is. Well, it's worth, if you're an 8-year-old, you won't necessarily know, it's not something we're born with to know that, colors can be described by 3 numbers. That's something that you have to, it's a thing to learn about the world, so to speak. And I think that, that whole corpus of things that are learning about the formalization of the world or the computationalization of the world, that's something that should be part of kind of standard education. And, there isn't a course, a curriculum for that. And by the way, whatever might have been in it just got changed because of LLMs and so on.
Significantly. And I'm watching closely with interest, seeing how universities adapt.
Well, so one of my projects for hopefully this year, I don't know, is to try and write sort of a reasonable textbook, so to speak, of whatever this thing, CX, whatever it is.
Mm-hmm.
What should you know? What should you know about like what a bug is? What is the intuition about bugs? What's the intuition about, software testing?
Mm-hmm.
What is it? What is it? These are things which are, they're not, those are things which have gotten taught in computer science as part of the trade of programming, but kind of the conceptual points about what these things are. It surprised me just at a very practical level. I wrote this little explainer thing about ChatGPT,
Mm-hmm.
and I thought, well, I'm writing this partly because I wanted to make sure I understood it myself, and so on. And it's been really popular,
Mm-hmm.
and surprisingly so. And then I realized, well, actually, I was sort of assuming, I didn't really think about it, actually. I just thought this is something I can write. And I realized, actually, it's a level of description that is kind of what has to be, it's not the engineering level description. It's not the kind of just the qualitative kind of description. It's some kind of sort of expository, mechanistic description of what's going on, together with kind of the bigger picture of the philosophy of things and so on. And I realized, actually, this is a pretty good thing for me to write. I kind of know those things. And I kind of realized it's not a collection of things that, I was sort of a little shocked that it's as much of an outlier in terms of explaining what's going on as it's turned out to be. And that makes me feel more of an obligation to kind of write the kind of, what is this thing that you should learn about the computationalization, the formalization of the world? Because, I've spent much of my life working on the kind of tooling and mechanics of that and the science you get from it. So I guess this is my kind of obligation to try to do this. But I think, so if you ask what's going to happen to like the computer science departments and so on, there's some interesting models. So for example, let's take math. Math is the thing that's important for all sorts of fields, engineering, even, chemistry, psychology, whatever else. And I think different universities have kind of evolved that differently. I mean, some say all the math is taught in the math department. And some say, well, we're going to have a math for chemists or something that is taught in the chemistry department. I think that this question of whether there is a centralization of the teaching of sort of CX is an interesting question. And I think, the way it evolved with math, people understood that math was sort of a separately teachable thing, and was kind of an independent element, as opposed to just being absorbed into. Now, so if you take the example of writing English or something like this, the first point is that at the college level, at least at fancy colleges, there's a certain amount of English writing that people do, but mostly it's kind of assumed that they pretty much know how to write. That's something they learnt at an earlier stage in education. Maybe rightly or wrongly believing that, but that's different issue. I think it reminds me of my kind of as I've tried to help people do technical writing and things, I'm always reminded of my 0th law of technical writing, which is if you don't understand what you're writing about, your readers do not stand a chance. Yeah. And so it's I think the thing that has when it comes to like writing, for example, people in different fields are expected to write English essays, and they're not, mostly the history department or the engineering department. They don't have their own, it's not like it's a thing which sort of people are assumed to have a knowledge of how to write that they can use in all these different fields. And the question is, some level of knowledge of math is kind of assumed by the time you get to the college level, but plenty is not, and that's sort of still centrally taught. The question is sort of how tall is the tower of kind of CX that you need before you can just go use it in all these different fields. And, there will be experts who want to learn the full elaborate tower, and that will be kind of the CS, CX, whatever department. But there'll also be everybody else who just needs to know a certain amount of that to be able to go and do their art history classes and so on.
Yeah, is it just a single class that everybody is required to take?
I don't know. I don't know how big it is yet. I hope to kind of define this curriculum, and I'll figure out whether it's my guess is that I don't know. I don't really understand universities and professoring that well, but my rough guess would be a year of college class will be enough to get to the point where most people have a reasonably broad knowledge of, will be sort of literate in this kind of computational way of thinking about things.
Yeah, basic literacy.